So we're going to continue with ellipses. Continued. All right. So when we have an ellipse, here's our ellipse, right? We have this center in the middle, and on our vertices, these are our co-vertices. There's one more point we need to talk about. There is a point that happens inside our ellipse that is the same distance every time we move it. This point falls on the major axis. So on this axis right here, on the major axis, there's a point called the foci. It happens on both ends. This is called a foci. The foci is the same, it's the same distance to either side of the ellipse. Okay? That's what it actually represents. The distance from the center to where this foci is the value little c. All right, to find the foci, we simply take our denominators, our a squared, which is underneath the long way, right? And our b squared, which is underneath the short way, we subtract them, and that gives us our c squared. So it's very close to the Pythagorean theorem, but instead of it being plus, it's a minus. So for example, okay, if I had, and we'll just use one where the center is at 0, 0. If I have x squared over, let's say, 36 plus y squared over 25, right, equals 1. All right, so let's graph this to begin with, and then we'll talk about what we have. So, our center is at 0, 0. Underneath x, we have this 36, so we know we're going to the right 6 and the left 6. We're going up 5 and down 5. All right. Here is my ellipse. Okay, so there is a point that falls on this major axis called the foci. That's what we're going to find. So we're going to take our a squared, the bigger of the two denominators first, and subtract the other one. Gives us our c squared. 36 minus 25 is 11 equals c squared. So c is the square root of 11. And we're going to leave it that way, but just so you guys have an idea, the value of that is about 3.3. So I'm going to say that for a second. So on our major axis, from the center, that foci falls about here and about here. So if you can imagine your ellipse being drawn beautifully, the distance from here to the ellipse and here to the ellipse this way should be the same length, right? Same thing from here to here. That's what they're talking about. We are going to be finding the foci today, and it always falls on the major axis. Okay? All right, so here's what I want to talk about first. So here's example number 1. I'm going to ask you to make sure I know what I'm talking about first. Sorry. All right. I'm going to ask you to identify the center, the vertices, and the foci. Okay? Now, the reason I'm saying that is because the foci and the vertices fall on the same axis. I can't spell. My goodness. Okay. All right. So if I give you the equation, let's say x squared over 81 plus y squared over 36 equals 1. All right. First of all, center. Our center in this case is at 0, 0. The vertices are the bigger number underneath these. So our vertices fall on the x-axis, right? We're going to take 81 and we square root that. We get plus and minus 9. And because it's underneath x, you've got to add that to our center. So our vertices are going to be at plus and minus 9 and 0. Our foci. Our foci are also going to fall on the same axis as our vertices. Find our foci. We take the larger denominator minus the smaller denominator. Set that equal to c squared. 81 minus 36 is 45 equals c squared. And of course, we are in pre-calc, so we've got to simplify that. So c equals 45 is 9 times 5, so this is 3 root 5. And so I'm going to add and subtract that from the center. So my foci is going to be plus and minus 3 root 5 and 0. That's the only real new thing we're doing today is adding this foci. Okay? So, I think, knowing you guys the way I do, especially everybody that's here today, you like it when we do like a table to use. All right? So, here's the tables we're going to do. This is what I think we should do. If we have a ellipse that's stretched along, like side to side, right? I'm going to call it side to side. Side to side. Our equation to begin with is x minus h squared over a squared plus y minus k squared over b squared equals 1. Right? That's that equation we've been talking about. So, our center is at hk. Our vertices are always at the h plus and minus the a value, k. Our co-vertices, that's what you were doing yesterday, are at h and k plus and minus the b value. Our foci are at h plus and minus c and k. And then I am going to add 2 more things today. Your major axis length is equal to 2a, and your minor axis length is equal to 2b. All right? So, that is our parabola, our ellipse, excuse me. If our ellipse is stretched side to side. If it's stretched up and down, so we're going to call this up and down. Again, our equation is very similar. We have x minus h squared over b squared, because that's the smaller axis, plus y minus k squared over a squared equals 1. All right, so our center is still at HK. Our vertices, this time because our vertices fall on the y-axis, h is going to stay the same, and k is going to be plus and minus the a value. Our co-vertices are going to be h plus and minus the b value, k. Our foci is going to be the same as our vertices. The h stays the same, and it's going to be k plus and minus the c value. Our major axis is still 2a, and our minor axis is still 2b. All right? So when we find these things, we can refer back to this. I think that'll be the easiest way to do it. So, let's try one. Example number 2. So on the worksheet today, as you're looking at the worksheet today, I'm going to ask you, this is like 7 through 12 will do. I want you to identify the center, the vertices, and the foci. All right? So we're finding three things to begin with. Say I have x minus 2 squared over 16 plus y minus 4 squared over 36 equals 1. All right? So, looking at this equation, this is stretched bigger on the y-axis. So we automatically know we're going to use this column or this side of our table. Right? All right, so our center is at 2, 4. Our vertices, okay, our vertices. Now, when we're stretched this way, our vertices are going to be, I think it's easiest if I write it 2, and then I'm going to write it out this way first. 4 plus and minus a. So now our a value is the square root of 36, which is plus and minus 6. So my a value is 6. So my vertices are 2, 4 plus 6 is 10, and 2, 4 minus 6 is negative 2. Everybody's okay with that? Foci. The foci is always your h value and then your k plus and minus c. So we still have to find the c value. To find c, we subtract our denominators. So 36 minus 16 equals c squared. 36 minus 16 is 20 equals c squared. So c equals, if I square root 20, I get 2 root 5. That's plus and minus 2 root 5. So in this case, my foci, my c, is 2 root 5. So I get 2 and 4 plus 2 root 5, and 2 and 4 minus 2 root 5. All right, writing this out can sometimes help you when you go to write these. So let's try another one. Here is example number 3. All right, and again, I want you to find your center, your vertices, and your foci. All right, let's say I have x plus 3 squared over 81 plus y minus 2 squared over 25 equals 1. All right, so there's, as I said, there's a few different ways to approach it. Why don't we try this one a little bit differently, and you guys can tell me which way you like better. So let's just start by detailing what some of the stuff is we have. First of all, we know our center, because you guys are well practiced with finding the center, right? Our HK is negative 3, 2. Okay, there's no question with that, right? Let's figure out our other values. Our A value in this case is the square root of the bigger number, which is 9. Our B value in this case is the square root of the smaller number, which is 5. And we still have to find our C. To find C, remember it is 81 minus 25 equals C squared. Oops, so if we go ahead and subtract those, 81 minus 25 gives us 56. So we have 56 equals C squared. And 56 is actually 2 root 14 equals C, or plus and minus. All right, so our C value is 2 root 14. Okay, so when we do our vertices, this time this is stretched side to side. The bigger number is under X, so that's what's going to change. So we're going to take our vertice in negative 3, and we're going to plus and minus the A value. Oops, comma 2, sorry, my bad. Let me get that back in there. Comma 2. All right, so my A value is 9. I'm going to plug 9 in here. So my vertices are -3 plus 9. So -3 plus 9 is 6 and 2. And my other one is -3 minus 9, which is -12 and 2. My foci, let me move it up a little bit. My foci, remember, are my H value plus and minus C and 2. So C in this case is 2 root 14. All right, so my foci then are going to be -3 plus 2 root 14, comma 2, and -3 minus 2 root 14, and 2. All right, so you guys tell me, do you like it better if I write these over here, or do you like it better the other way we did it? Or does anybody have a preference? Okay. Okay, sounds good to me. All right. Let's try another one, and I'm going to really pile it on. Are you guys ready? Say yes. All right, here's my next example. Example number 4. Okay, this is going to be very similar to numbers 13 and 14 on the worksheet. Okay? I am going to ask you to identify the center, the vertices, the co-vertices, the foci, the length of the major and minor axis. Major and minor axis. All right. So, let's say I have x plus 10 squared over 100 plus y minus 6 squared over 36 equals 1. All right. So you can tell that this is stretched side to side. So in that table we made, we're going to use the first list. Okay. And starting with, we know what our center is. So I'm going to put my center right here. My center is at -10, 6. Right? All right. So my A value is the bigger number, the square root of the bigger number, which is 10. My B value is the smaller number, the square root of the smaller number, which is 6. And I need to find C. To find C, it is my denominator subtracted. And then we're going to square root it. In this case, 100 minus 36 is 64. So C equals 8. All right. So let's start with our vertices. Because the bigger number is under x, we are going to be taking our h value and adding and subtracting a to that, right? Writing what's in our table up on top. Okay? So we actually have -10 plus and minus 10 and 6. So we have -10 plus 10 is 0, 6. And we have -10 minus 10, or -20, 6. All right, let's talk about the co-vertices. Co-vertices, if you look in the table, it says your H stays, but K add and subtract B. All right, so going back to our center, -10 is going to stay. We're going to take 6 and add and subtract our B value of 6. All right, so we have, for our co-vertices, -10, 6 plus 6 is 12, and -10, 6 minus 6 is 0. All right, your foci is next. Foci. For your foci, again, if you look at our table, that's H plus and minus C and K. we have our h is negative 10, plus and minus our c value, and k is 6, right? All right. So we have for our foci, negative 10 plus 8 is negative 2, 6. We have negative 10 minus 8, which is negative 18, 6. Okay, at the beginning of this problem, I asked you for the length of the major and minor axis. For the major axis, major length, we'll call it, that is simply 2a. Well, we have our a value written on the side right there. A is 10, so this is simply 2 times 10 equals 20. Our minor length is 2b, or in this case, our b value we said was 6. So it's just 2 times 6. Or 12. All right, so out of all those things, I think if you refer to your table and you write down exactly what it is you're adding and subtracting, I think it will help a lot, okay? Is there a question on any part of what we've added today? We've added a foci and the major and minor length, which shouldn't be a big deal. Any question at all? Okay. All right. So if there's no question, that's all for me for today. I am going to post this video as well, and I'll probably just do a copy of the notes in there in case you need to refer back to anything, if you missed anything, if one of your friends didn't get on, it'll all be there for you. All right. That table, I'm telling you, you're going to want it there to refer back to. On your worksheet today, the first 6, I just want you to graph it. Don't even have to tell me anything, just graph it. Super easy. But then the other ones after that, you either have to identify vertices, foci, and then the last 2 are just like this last problem we did. All right? You guys have a great, great afternoon. Enjoy. It's sun shiny out right now. Well, it is here. Cold, but sun's shining. So enjoy what you can, okay? You want snow? It's coming before you know it. Did you hear that New York's supposed to get like 20 inches? I know. Yeah, they're supposed to get 20 inches and like 50 mile-an-hour winds. It's supposed to be like nuts, like the biggest storm in like 25 years or something. No, I don't think so either. Right. Yeah, I agree. I mean, even I mean, it would be a battle just to get out to shovel when it's all done, I would think. I'm with you. That's all I'm gonna do. Well, that's all I do anyway, but you know. Oh goodness. All right. So we have 3 days left. Technically, I'm not assigning anything on Friday at all. We're just gonna go over the homework and that's it. So technically, we have 2 days left, and then hopefully we're gonna be back together after Christmas. I'm so hoping. All right. I miss you guys. I do. Just so you know. Yeah. Yeah, but like I spent more time with you guys than like my own family, my kids. I haven't seen my kids at all. So you guys are my kids. At least I get to talk to you every day, but it's still, you know, I don't know. It's very lonely at home. So Alexa, I think you hang out with your dog the most, don't you? Oh. Wow. Yeah, and you don't want them to go back out when it's like cold like this and they're wet. You got to make sure they're super dry. Oh, too. Yeah. Especially until the snow comes. Doesn't the snow kind of keep them a little bit cleaner? Oh, I can imagine. But oh, that's sweet.